Hi, my name is Victor, and I have a big pimple on my nose. You're with Revit Experiments. Today I'm going to show you how to make these things as panels in Revit. And actually I'm showing this because I got intrigued. A guy asked about this in one of the Revit related groups on Facebook. So I decided, yeah, that seems interesting. Why don't I make a tutorial about this? So he asked how to make that thing inside of a diamond curtain panel family. And there is actually not such thing as a diamond family in Revit, but there is a rhomb one, which I believe is what he meant by this. Anyway, let's get to it. This is what I got in Revit. So this is the piece that he asked for generally, and these are indeed curtain panels, rhomboid curtain panels. And we have three types here. We have the main one, and it has three types. We cannot change it right now because all of this is actually made in a mass. Now, I have to mention, I asked if we are talking about modeling those kind of panels for an architectural project, or is it going to be for facade engineering? Because in facade engineering we have to deal with precise details and much more information. So actually for facade engineering, most probably we won't be using curtain panels, but we would use dynamo and generic models if we are talking about building that facade from a facade engineer point of view. But here we are talking about the architectural model, and this is actually nice to have as a curtain panel because we can change it easily. And if we are going to do it as facade engineering model, of course changes are a bit more, it's usually a bit more cumbersome to make changes, but actually nowadays with Dynamo it's a lot easier. So what do I mean that we have these changes? We can always go to that mass and just make it shorter, for example, and all these panels are going to adjust accordingly. And now I can actually go here and actually to go here I have to click on edit in place first because this is a mass. And now I can go and I can select a different type of panel, and I can also go there and for example I can edit this type here, and here we don't have mapped parameters, but in the main panel, so that would be this one, we can actually modify some fillet parameters, the profile thickness. Like if I make this 250, you can see that those profiles are going to become a lot thicker now. Let me zoom in a little bit so we see that more clearly. The thing is, these panels are fully parametric, so we can change them a lot and in many ways, and because of this geometry, which is the interesting thing in that panel, we need to have all those different types of parameters that change the character of the shape. And this thing here now, for example, it's I just named it CH. I'm going to show you how to build this from scratch. But if I changed it to let's say 1000, oops, that's not what I meant, and I hit apply, you can see how the character of this changes. Then I can also change that fillet parameter here. I can go and change the other one as well. I can change the character of the curve that you see here. It is another parameter here, like I can do this 0.15, which is going to change the curve, as you can see, until you find what you like. And I think it is pretty similar to what we have here as shown. And once again, like, this is the architectural model. We're not going into details like those ones here. And how is this modeled? If I go here and click on edit family, I can see this is my rhomboid panel, and inside I have a few panels loaded in, and this is actually an adaptive model, adaptive component. Okay, if you want to learn how to do this from scratch, from now on I'm going to show this, and it might get a bit lengthy, so be prepared. And this is a good time to tell you that if you would like to give me a like and subscribe, I would really appreciate that. Okay, so now I'm going to close everything that is open here. Apart from the project, and on the other side, or actually I'm going to just select that face and drag it, something like this, and I'm going to create a divided surface here. So when you create a divided surface, you can select the pattern here, and in this example we're going to work with the rhomboid pattern. So it looks like this, and then if you have a panel, you can load a panel. Now let's go and create a panel from scratch. I'm going to new family, and I'm using the metric library. These are my family templates. So I'm going to go to metric curtain panel pattern based, which is not the same as the curtain panel wall based. And by default, when this is opened, it is showing you the rectangle on grid, and you can click here and select the other patterns. So I'm going to select rhomboid. And here, this is how the rhomboid looks now. And I can actually, just for the sake of the preview, I can go here, select the grid, and I can change this number just to work with similar proportions. If we go back to the photo, we can see that these are quite similar. That's why I nested a family inside. But still, we have to tell that adaptive component we're going to create and load where exactly to be placed in that curtain panel. So to do it, I'm just going to create the diagonals of that thing. And I'm clicking here on the spline through points, which is going to give me just a line. And I'm clicking here on is reference line to create that line. We cannot see it very well because it is overlapping with the grid, but it is there. And I'm going to do this again between those points. Click here, spline through points, is reference line. Good. Now that this is done, actually I'm going to select and hide this because I don't need it. I need to add 4 points here and to find a way to control them parametrically in a way that works for us. So if I select the point here, point element, and draw on face is enabled, I can host these points on the curves, and I'm just placing the 4 points on. Pretty much I'm eyeballing it at this moment, but then I'm going to select that point, and you can see here there is a normalized curve parameter that changes. So this parameter is pretty much where that point is on this line. But I don't want the normalized parameter now. I want to control this as an actual distance. So I'm going to click here and click on segment length. And I'm going to set it to, let's say, 500 or something. And I'm going to set this as a parameter. So depends on what you want to do. You might want to use it as a type or as an instance parameter. Here, most of the parameters in the curtain panel family I'm going to make as type parameters. So this is going to be my fillet one. Okay. And I'm going to do the same for the other one. But here, when I click on segment length, you can see that the number is much larger because it's measuring from the beginning. But I can tell it here to measure from the end, and then I can connect it to the same parameter. And now these two are connected to the same parameter, which means that when I move one of them, the other one will move accordingly. Which is nice, because we have that symmetry here. This is what we need. And I'm going to do the same for those two. Of course, I'm going to connect it to another parameter, because those two values are going to be different. I mean, the angle here is different than the angle here. Good. And a good practice is when you start a new family, just save it, just in case, to have that backup. So present romp family. Okay, and this is all I need to begin with. Then I'm going to create my adaptive component family. So I'm going to family, metric, generic, model, adaptive. And I'm going to go to the top view. Here I'm going to place 4 points. 1, 2, 3, 4. I'm going to select them like this and make them adaptive. Next thing I'm going to do is I'm going to create those lines between the points. Like this. And make them reference. Good start. Next, I'm going to do the same thing that I did just a moment ago with those 2 points here. And again, I want to use a distance. So I'm going to create this new parameter here, and I'm going to name it ch1, but here it is important that we make this as an instance parameter. The other one as well, but from the end, and connect it to the same parameter. Then I'm going to create a point, and I'm going to host that point on the ones that we just created. So I'm going to use set here, and I'm going to select the plane defined by this point. Then I'm going to the point, and I'm going to click here, place on work plane. And because this is the current work plane, I just make sure that this point is now hosted on the other one. And I'm going to make the same here, like this. Now we can see that these points actually, when we move them here, they have this offset parameter, but this is now negative value, and I don't really like that. So just to change it, because I want to use a positive value, one way would be to create another parameter and say, okay, make this one equal to the negative value of the other parameter. But we can simply go to this point here and set the rotation angle to 180. Same thing here. And now this direction is going to be the positive one. So I'm going to set this to a number, and this number becomes a parameter which is going to be named profile thickness, or just thickness. It's generally good to name your parameters in a simple but clear way. Simple and clear. Yeah, I don't know. It should be clear, but shouldn't be really too descriptive. We don't want to use sentences for parameters. Now, here we are going to have that arc. And how to make this arc? I'm going to use a simple way, and I'm going to use a spline through 3 points, or you can use an arc through 3 points if you really want to make it more buildable in a way. But before that, I'm just going to put another point here on this line and on this line. And again, I'm going to make this a parameter, but I'm now going to use it as a normalized curve parameter. I'm still going to change this to the end. So I'm going to name this chamfer 1. Make it an instance. I mean, I'm not thinking too much about the names now, but usually you should, especially if someone else is also using those families, you should name them correctly. So then I'm going to create a line here, make it reference, and another one here between those 2 points, and make it a reference. And I'm going to repeat that same thing, placing a line here and here. And this is going to be my chamfer 2. So now I can just select those 3 points, and I can make a spline through them and make it a reference. So I'm going to do a spline here, make it a reference line. And now these 2 parameters that we made, they are changing the character of the spline. So that's why I want them as parameters. And you can see, because they are connected to the same parameter, if I change something here, it changes here as well. This is really important. And I'm also going to create a line between those 2 points. So now I have to create the height of this profile, because even now I can actually select that geometry and say create shape, and it's good, but it's not what we want. So how to create the top? Well, first thing I'm going to do is I'm going to place 2 points on top of my adaptive points. And offset them. I'm going to the offset parameter, I'm going to create a new one, and I'm going to name it height. Like this. Connect the other one to the same parameter. And I'm going to go to the parameters and give it some value, let's say 300. Of course, I'm going to connect those 2 points with a reference line. And I'm going to need another line here that would determine the top thickness. So there are multiple ways to do this, and one way is to use trigonometry, but even though in some families I use a lot of trigonometry to keep them stable, here I think we can make it in a more geometrical Euclidean approach, if you will. So I'm going to draw a point hosted on that plane, on that line here. And then I'm going to create another point here. And this point I'm going to move here. This is going to be our thickness. Then I'm going to create another point here, like this. And give it some offset. And I'm going to connect those 2 points with a reference line. Okay. Now, why did I make that line so short? Well, I'm going to create another line on that line. So I'm going to set this as my work plane. And I'm going to pick a line on that work plane here and lock it to that line. And I'm going to extend the ends of that line. So I'm going to drag that end a little bit and then I'm going to drag the other end of the line, actually like this. If I hide those, now that I have dragged them, I'm going to go to the reference level. This is important, and then I'm going to align the ends of that line, so that point here, and I'm going to lock it, and I'm going to do the same here, that point, and I'm going to lock it. These locks are very important. So now if I change this parameter here, that line is going to adjust. Isn't that beautiful? Good. So now it's actually time to create this top thickness parameter, like this. And I'm also going to make this line a reference line. There are some differences between using reference and model lines, apart from reference lines being invisible and model lines being visible. But as a general rule of thumb, if we are going to create geometry in a really parametric way, like what we are doing right now, it's better to use reference lines. And I'm going to put 2 more points on this line, and that point I'm going to put in the beginning, or should I say the end and the beginning, using the normalized curve parameters. What does it mean, normalized curve parameters? Every curve has a start and end, so 0 is the start of the curve and 1 is the end of the curve, no matter what's its length. So that's why these are extremely powerful for making adaptive families. So I'm going to connect those two with a reference line, and those two as well, like this. And now we have everything we need to create the geometry. I'm going to save that as present adaptive component family, adaptive component profile. Okay, so now, like, good job if you made it so far. I warn you, it's going to be a bit lengthy. I'm selecting all the profile lines and I click on create form, which gives me the desired shape. Pretty much, let me turn it on shaded here, pretty much what we expected to see here. Good. Now I'm going to load this into my Rhomb family and place it 1, 2, 3, 4. Here it is important that we place all the families in the correct way. So you saw what we did: 1, 2, 3, 4. Now we're going to go 1, 2, 3, 4. This is now flipped, but we're going to fix it. Let's just place the other ones. 1, 2, 3, 4 in the same order in which we made the adaptive points in that family. So 1, 2, 3, 4. Since the family itself is symmetric, we don't need to care too much about this, but still we should always know how that adaptive component was made. And now we have it. So for example, if we want to control different adaptive components in different ways in the host family, we could connect those instance parameters to different parameters here, but I'm just going to select them all, and that ch1 is going to be a ch1 here. Here is going to be a type parameter. The height is going to be the same for all of them, so let's create the height in the host. Profile thickness. Like this. And of course the top thickness. Profile top thickness. And the chamfers we might want to change in a different way. But actually, looking at the family, no, they will all be the same. What we might want it to do back in the adaptive component family is have one parameter for the left part here and another one for the right part, so we could connect them to different parameters depending on is it that angle, the narrow, the small angle here, or is it the wide angle here. But for now, let's just assign them to one parameter. Chamfer 1. Is it chamfer? I'm continuing with that name, but yeah, maybe it should be something else. Tell me in the comments what's the best name for that parameter. Okay, like this. Good. And now I can load that into my project. Go to 3D, go here, and it's going to appear here. Present Rhomb family. Okay, good. Adjusting the parameters, of course, will make the things needed. So let's say that should be 850, let's say. This fillet 1, let's make it smaller, like this. Maybe not that small, maybe 500, and then the other one is going to be 500 as well. Let's try like this. And good. I actually want to make that. So here we just need to adjust to the size. That depends on the shape. Okay. And of course we can try and change the character here. So let's make this 0.7. Actually, I like that. Let's make this 0. If it's 0, it's going to be a straight line, which is neat if you want that. And if it is 0.4, let's say, it's gonna go kind of inwards again. So I believe around 0.25 should be best in this case. Looking good to me. So what's left is to tell you how I made that and that. That thing here, I just deleted a few panels like this. You can, oops, you can just delete them. Go and say, I don't want you. I don't want you either. Go away. Sod off. Then I can go here, select the surface underneath, enable that surface, go here to surface representation, surface, and enable the nodes. The nodes are these points. And then I can press CM for component, and this is going to give me a way to just create that curtain panel component as an adaptive model. And now I can go here and place it on those nodes like this. It would be probably smarter if I go to the back side, or if I have hidden the panels, but anyway, so I'll go 1, 2, 3, and now finally 4. And I'm going to need to flip it like this. And of course I can go here, edit type, duplicate that family. Let's say that's going to be the big panel. So I can actually go here and change some of these parameters, or I can change its instance parameters. So the profile thickness, which we made as an instance parameter apparently, I can make it 250 because it would look better probably. And then still in the type I can make this 100, like 1300 to make it wider. And I'm going to double these 1000, 1000. I don't know if it's gonna work. Yeah, that's definitely way too much for that one. That one should be 600, let's say. Nice. Okay, I like that. And how I did these ones? Well, I could do it in the same way, but actually I went and created a new rhomboid family. So let's go here, new family, curtain, model, pattern based, rhomb, like this. And I went and divided this in 4 like this, middle to middle. Oops. Like that. Made those reference as always. And I hosted a point in the middle of one of them. So then I would go to my rhomboid family and I'm going to load it in the new one and just place it 4 times like this, and you know how to do the rest. And of course, like, to do a good family, this should probably be in its own subcategory. It should have a material assigned, etc, etc, but you know all of this. The tutorial is long enough like this anyway. So tell me in the comments if you like that tutorial. Tell me what else do you like to see. And if you wanna go and use Dynamo in your project, if you are interested in using Dynamo, I have to say I created a really nice Udemy course. And you know, it's a 10 hour and a half long course. It has 42 lectures. It has everything covered from beginning to the end. And it has one unique section, which is the last one. How to solve complex problems with Dynamo, where I'm teaching you my problem solving algorithm, how I think about solving problems. So first, all these sections are giving you concrete examples in Dynamo, how to do this, how to do that, a variety of examples, different things that you can do, all the basics, and then I'm showing some scripts made for real projects, and I'm breaking them down, showing how these principles apply there. The course is really good, and you know what's really good? It's good that Udemy actually gives you a 30-day money-back guarantee. So you're covered, you're saved. So the link to that course is going to be under the video as well. And I'm also going to share those families with you if you go to my website, revitexperiments.com. I'm going to put them somewhere here in the downloads. And you might want to as well subscribe to get other things here. But I'm going to put all those links later. So thank you a lot for watching. Until the next time, when hopefully I won't have that pimple on my nose. See you. Bye bye.